Welcome to Science Beyond Sleep. Tonight, we going into a world where whispers matter more than echoes, where a single breath might shift the future and silence carries power. Let me ask you something gentle, yet strange. What if a single flap of a butterfly's wing could change the course of a storm across the world? It might sound like a bedtime fable, but it's something real, a scientific idea that says even the smallest act can ripple outward far beyond what we can see. This is the butterfly effect, a quiet force inside chaos. A truth about unpredictability, pattern, and the surprising power of small things. So breathe slowly. Let your thoughts uncoil. And let's begin this journey, not with thunder or lightning, but with something softer. A wing. A whisper. A beginning. Imagine you're standing in a field. The air is warm. Still, you feel it brush your skin like a sigh. Somewhere nearby, a butterfly lifts into the air. Its wings barely move, soft, delicate, fragile, and yet that motion stirs the air, a shift too small for us to feel. But maybe, just maybe, that shift carries on. Maybe it nudges a breeze. Maybe that breeze swirls into something greater. And maybe, far away, days or weeks from now, a storm changes its path. A cloud releases its rain a little earlier. A lightning bolt strikes a different tree. All because of a wing beat no one noticed. That's the image. That's the wonder. And that's where the idea of the butterfly effect was born. Not in storms or science fiction, but in a question: how much does a small thing matter? The butterfly is a symbol. It's not really about insects, of course. It's about sensitivity. It's about systems that respond wildly to small changes. And that symbol, the gentle flutter that changes the future, came from one of the most surprising corners of science: weather prediction. Back in the early 1960s, a meteorologist named Edward Lorenz was running a computer model to simulate the weather. He'd typed in some numbers, temperatures, pressures, wind speeds, and let the program run. But one day, he made a tiny adjustment. He rounded one number slightly, just a decimal point different. To his surprise, the weather pattern that came out of the model looked completely different from the original. The difference was minuscule, barely noticeable, and yet it grew and grew until it shaped the entire outcome. That's when Lorenz realized even the tiniest change in a system can lead to wildly different results. And that realization gave birth to what we now call chaos theory. Not chaos as in disorder, but chaos as in unpredictable beauty. A world where things don't always follow neat, straight lines. A world where a wing beat can echo like a drum. The idea of the butterfly effect is quietly radical. It suggests that perfect prediction might be impossible, not because we don't have the tools, but because the universe itself is sensitive beyond belief. In a world ruled by chaos, a seed of change can grow into a forest of difference. And that makes everything we do, every choice, every pause, every breath, just a little more sacred. Tonight, we begin our descent into that strange, shifting world, not with equations or charts, but with the soft hush of curiosity. Because the butterfly effect isn't loud. It's not violent. It's quiet, delicate, but it never stops moving. It began, as many great stories do, with a mistake. A quiet one, not a disaster, just a small, unnoticed rounding of a number. In 1961, a man named Edward Lorenz, a mathematician and meteorologist at MIT, was running simulations of weather patterns. He had built an early computer model, a set of equations designed to mimic the atmosphere. It was primitive by today's standards, but it was revolutionary. Then, one afternoon, Lorenz decided to rerun a weather pattern he had already simulated. But instead of typing in the full set of numbers from the original run, he shortened them, just a little. He rounded a number like 0.506127 down to 0.506. He assumed, logically, that the result would be nearly identical. After all, that's a difference of less than 1 part in 1,000. But when the simulation finished, something strange had happened. The output wasn't just a little different. It was completely different. The model had gone on an entirely new path. Skies that had cleared before now filled with storms. Winds that had died now grew wild. All because of one tiny, tiny difference. That single moment, that small rounding error, was a crack in the wall of predictability. Lorenz stared at the results, stunned. He had found something no one expected, a system that was both orderly and wildly unpredictable, a system that followed clear rules, and yet was nearly impossible to predict long-term. That he called this phenomenon sensitive dependence on initial conditions. And it became the foundation for what would later be known as chaos theory. Chaos theory isn't about randomness. It's not about everything being unknowable. It's about the edge between predictability and surprise. In chaotic systems, small inputs lead to huge outputs. Cause and effect still exist. They just behave in strange, beautiful ways that a simple image can help. Imagine placing a marble on top of a hill. If you shift it even slightly left or right, it'll roll down a different side, leading to a completely different valley. That's the butterfly effect in motion. It's not the marble's fault. It's just that the system is so sensitive. It turns whispers into outcomes. Lorenz's discovery sent ripples across science. It challenged the idea that if we simply had enough data, we could predict everything: the weather, economies, even life itself. But now, we knew, even perfect equations don't guarantee perfect foresight. Because if you can't measure something exactly, you might end up watching a hurricane where there was once only a breeze. And so, from that small moment in a lab, the butterfly took flight. A decimal point became a symbol, and we began to see the world not as a machine, but as a living, shifting rhythm of interwoven patterns. It's a humbling thought that we live in a universe that remembers its beginnings and multiplies the tiniest moments into grand, swirling outcomes, and it's only the beginning. Imagine trying to predict the path of a single leaf in the wind. You know the laws of motion. You can feel the breeze. You even understand the forces at play. But once the leaf lifts off the ground, all certainty fades. Because every gust, every swirl of air, every tiny change in pressure can send it somewhere else. That's what scientists mean by sensitive dependence on initial conditions. It sounds complex, and in mathematical terms, it is. But in feeling, in meaning, it's beautifully simple. It means this: small changes at the beginning can lead to big differences at the end. And in chaotic systems, like weather, like traffic, like ecosystems, like your own mind, this truth is everything. Let's go back to Edward Lorenz for a moment. When he discovered that rounding a single number in a weather model caused a completely different forecast, he wasn't just discovering a flaw in his system. He was uncovering a law of nature. In many systems, especially natural ones, we can't ever know all the starting conditions with perfect precision. We can get close, but we can't measure every molecule, every flutter of air, every shift of temperature. And because of that, our predictions eventually unravel. It's like setting out on a journey across the ocean. If your compass is off by even half a degree, you might land on a different continent. Not after a mile, but after 1,000. That's sensitive dependence. One of the most famous visual representations of this idea is called the Lorenz attractor. It's a mathematical image, a 3D spiral that never repeats itself. It looks almost like the wings of a butterfly. And as the system evolves, the pattern loops endlessly, never crossing the same point twice, but still held within a kind of invisible shape, a strange order inside chaos. This attractor isn't random. It's determined by equations. But the paths it traces are so sensitive to starting values, so dependent on initial input, that no two trips through it are ever the same. Now, pause for a moment. Think about your own life, your habits, your moods, your reactions. Think about how one comment in the morning, one smile, one slight delay can echo through your day. Change the way you drive, change what you notice, change who you meet, and in time, maybe even change your future. If that's not philosophy, that's physics. It's how complex systems work. And you, like everything else, are a complex system. Sensitive dependence doesn't mean everything is chaos. It doesn't mean nothing matters. It means everything matters, at least a little. It means the universe has a kind of poetry in its unpredictability. And within that, there's room for surprise, for wonder, for stories that never repeat the same way twice. Even in stillness, change is happening. Even in sleep, the smallest shift can turn the tide of a dream. Even in thought, a quiet realization can reshape the days that follow. And so we begin to see the butterfly effect isn't just about science. It's about being alive in a system where small is never small that we used to believe the universe was. A clock, a vast, ticking machine, perfect, mechanical, and predictable. If we only knew the rules well enough, we thought, we could calculate everything. Where a planet would be 1,000 years from now, how the wind would blow next week, even how a human life would unfold. This dream of perfect knowledge is old. It gave rise to science itself, to mathematics, to astronomy, to physics. And for a time, it almost seemed true. The laws of Newton gave us planets in motion. The rules of thermodynamics gave us engines and industry. The world was ordered, or so it seemed. But then, cracks began to show, first in the weather, then in biology, then in the folds of the brain, the patterns of traffic, the motion of waves, and scientists began to realize there is no such thing as a perfectly predictable system, at least not when it's complex. Because small uncertainties are everywhere. And once time begins to move forward, those tiny seeds of difference bloom into wild, untamable forest. That's not failure. That's nature. The weather is perhaps the most poetic example. We can track it with satellites, measure it with radar, feed it into supercomputers that run thousands of equations per second. And still, beyond a few days, it slips out of reach. Storms form where none were forecast. Rain disappears from skies that looked full. The problem isn't the model. The problem is the world. It's too sensitive, too subtle, too alive. Even a butterfly, even you, walking through the street can disturb a puff of warm air that changes a rising current, that delays a cloud's formation, that shifts the moment a raindrop falls, that nudges a storm, that moves a future. And yet, the universe is not wild chaos. It holds patterns, deep, strange, beautiful patterns. The spiral of a galaxy, the branching of a tree, the rhythm of your breath. These are not random. They are emergent, order born from complexity, a dance that doesn't repeat, but always remembers its rhythm. That is what chaos theory shows us. Unpredictability doesn't mean disorder. It means something deeper, something richer, a kind of structured unpredictability, a universe that plays jazz instead of marching in line. This is why your life doesn't go according to plan. Why love can arrive unexpectedly. Why success sometimes grows from failure. Why the smallest kindness or cruelty can echo through years. That it's not because life is broken. It's because it is beautifully unpredictable. Because it dances on the edge of certainty. Because it flows like water, not like code. And so we return to the butterfly, not as a myth, but as a mirror. A quiet reminder that in a universe like this, small things can, and do, change everything. Take a moment to imagine a still pond, glass-like, untouched. Now, imagine a single drop falling into it. It touches the surface, barely, and yet ripples spread outward in perfect circles, not just near the center, but across the entire pond. The surface has changed forever, even if the waves fade to invisibility. Nature is full of these moments. A falling leaf changes where an ant walks. A shift in the wind moves a pollen grain to a different flower. A seed lands in one patch of sunlight instead of another, and one day grows into a tree that shades a future village. That we often think of change in terms of big things, disasters, revolutions, inventions. But nature moves differently. It moves in quiet ripples, built on interconnection, sensitivity, and time. Consider a single bee. She visits one flower instead of another, pollinates one plant, misses the next. The fruit that forms feeds a bird. That bird migrates slightly sooner. A predator moves accordingly. And somewhere, a forest floor receives different nutrients than it would have. Tiny shifts, tiny causes, but each one carries change outward, quietly, beautifully. This is the ripple effect. It's not loud. It doesn't demand attention, but it changes the shape of things. Even the migration of monarch butterflies, thousands of miles across continents, depends on exact conditions, wind speeds, temperatures, and blooming patterns. A single week of early frost or a delayed rain can disrupt entire generations. And yet, they fly, delicate, tiny creatures whose lives ripple across nations. The more we study nature, the more we see it behaves like Lorenz's weather model. Complex, reactive, sensitive. Not random, but responsive. It listens to its beginning. This understanding has reshaped biology, conservation, climate science. It's why removing one species from an ecosystem can unravel the balance. It's why human-made climate shifts are not just numbers. They cascade, they ripple, they turn butterflies into hurricanes. And so, with gentle awe, we begin to understand. There is no such thing as a small act in nature. Every creature, every molecule, every shift in sunlight belongs to a web of consequences, delicate, infinite, and alive. Think back to a moment, seemingly small, that changed something for you. Maybe it was a text you almost didn't send, a glance exchanged with a stranger, a sentence someone said to you in passing, not even knowing its weight. But somehow, that moment led to something else, and then something else, until your life was shaped by it, not with a bang, but with a whisper. This is how the butterfly effect plays out in human lives, not just in science, but in memory, in identity, in the quiet chain reactions of choice that we often imagine our lives as paths, straight roads, forks we consciously choose. But more often than not, they're rivers. They twist and diverge with the tiniest changes in current. The things we say, the things we don't, the time we arrive early, the time we hesitate and miss a train. A small choice, what book to read, which seat to take, whether to speak or stay silent, can place us in the path of an idea, or a person, or a chance we never expected. These aren't grand cinematic moments. They don't come with music or spotlights, but they ripple forward with astonishing power. There's a story you've probably heard about how J.K. Rowling almost didn't get published. She was rejected again and again. But one editor, who happened to give the manuscript to his 8-year-old daughter, saw the child devour the pages. And that tiny moment, an editor bringing a book home, led to one of the most successful literary phenomena in modern history. Another story, Steve Jobs once audited a calligraphy course at Reed College. He didn't need it. It wasn't part of any requirement. But years later, that choice led to Apple computers having beautiful fonts, something we now take for granted. One small class, one ripple, a future transformed. Now think about how your own words might ripple outward. A compliment you gave that helped someone feel seen. A small act of kindness that made a hard day bearable. Maybe they never told you. Maybe you'll never know. But the effect is real. The butterfly effect tells us we are all part of something unfolding, not just in physics or math, but in the human story. Every action is not just an end. It's a beginning. Every choice is not just a result. It's a seed that we don't need to control the future. But we should understand our power in the present. And just as small kindness ripples outward, so can cruelty, so can inaction, so can silence. This isn't meant to burden you, only to awaken you, to remind you that your life, even in its quietest moments, is part of a grand, living pattern. And even if you never see the final result, you're shaping it, moment by moment, breath by breath. Next time you pause before acting, next time you hesitate to reach out, to show compassion, to do the brave or soft thing, remember this: small things change everything. Not all at once, but in time, always in time. History, in textbooks, often reads like a march, a series of great wars, famous speeches, political movements. But in truth, history is not a straight line. It is a web, a trembling net of moments, most of them small, a misstep, a pause, a word, and suddenly, the course of human destiny turns. The butterfly effect, this quiet idea that a small change can shape a large outcome, isn't just theoretical in history. It's visible, traceable, and at times, almost unbelievable. Let's begin in 1914. A summer morning in Sarajevo. A man named Gavrilo Princip is part of a group trying to assassinate Archduke Franz Ferdinand of Austria. Their first attempt fails. The bomb misses. The Archduke survives. The day moves on, but later, by sheer coincidence, Franz Ferdinand's driver makes a wrong turn. They end up on the same street where Princip, dejected and sure he had failed, was standing outside a sandwich shop. He sees the Archduke, draws his pistol, and fires. Those shots, the result of a wrong turn, began a war that consumed the globe. World War I. A cascade of alliances pulled nations into battle. Millions died. Empires collapsed. And out of that war rose World War II, the Holocaust, the Cold War, the modern Middle East, and the shape of the world we live in today. All because someone took the wrong street. Let's move a little earlier. To 1831. A young Charles Darwin is offered a place aboard the HMS Beagle. But he hesitates. He's unsure. His father disapproves. The voyage is almost canceled, but a family friend, Josiah Wedgwood, writes a passionate letter persuading Darwin's father to allow it. That letter, a single act of persuasion, resulted in Darwin joining the Beagle's voyage, which led to his observations of finches and fossils in islands. And ultimately, to the theory of evolution by natural selection. One of the most profound shifts in human understanding of biology, of our origins, of life itself, can be traced to a letter. One man, one opinion, one signature, a butterfly, flapping its wings. Now think of Martin Luther King Jr. He almost didn't give his most famous speech the way we know it. On that day in 1963, standing before the Lincoln Memorial, he was following his prepared notes. But then, gospel singer Mahalia Jackson, standing nearby, called out to him, "Tell them about the dream, Martin." And he did. He stepped away from the script. And the words, "I have a dream," rose into the hot August air. A moment improvised, born not of a plan, but of emotion, timing, and encouragement. That moment became immortal, a speech remembered for centuries. Now imagine if Mahalia had stayed quiet, or if Martin had stayed on script. History would still have turned, but differently, less powerfully, less poetically. That's the butterfly effect. The same is true of science. Alexander Fleming left for vacation in 1928, forgetting to clean up his petri dishes. When he returned, he noticed mold had killed off the bacteria he was growing. That mold was Penicillium notatum, and what Fleming had just discovered, by accident, was the first antibiotic, penicillin. A dirty lab, an overlooked dish, a new era in medicine. Millions, maybe billions, of lives saved. Now imagine if he had tidied up, if he had been slightly more careful, if that mold had dried out and disappeared before he returned. Modern medicine would have followed a completely different path. Sometimes, the effect isn't positive. NASA's Challenger disaster in 1986 was traced back to a simple rubber O-ring that failed in the cold. Engineers had concerns. Some even voiced them, but the warnings weren't loud enough. The launch proceeded. 73 seconds into flight, the shuttle disintegrated. 7 lives were lost, and space exploration was set back for years. Tiny part, huge tragedy. The butterfly effect doesn't choose sides. It's not always a gift. It's simply a truth. Small causes lead to large outcomes, for better or worse. And so we begin to realize, history is full of these moments. Each one of us, at any time, might be part of a thread that changes everything. That time you missed your bus. What conversation did it lead you to instead? That job offer you declined. Where might it have taken you? The letter you never sent. The question you finally asked. All these quiet moments are not footnotes. They are the turning gears in the grand story of time that we often think that only powerful people shape history. Presidents, inventors, generals. But the truth is more subtle, more democratic. It is the forgotten driver, the unpaid assistant, the janitor who sees something others miss, the passerby who speaks up. You don't have to be on a stage to move history. You just have to be a part of the web. And you already are. So next time you feel small, next time the world feels too big, remember, every turning point began somewhere quiet. A door left open, a decision made too quickly, a mistake, a kindness, a yes, a no. You are not outside the flow of history. You are inside it, rippling outward in ways you may never see, but which matter more than you can know. In school, we're often taught simple systems. You push a ball and it rolls. You boil water and it steams. Inputs lead to outputs, predictably, neatly, linearly. But most of the world doesn't work that way. Most of reality is nonlinear. That means the output isn't directly proportional to the input. Push a little and nothing might happen. Push a tiny bit more and the whole system flips. Nonlinear systems are sensitive. Tiny changes don't always lead to tiny effects. Sometimes they lead to explosions, collapses, new states of being. This is why weather forecasting is so hard. This is why ecosystems change suddenly. This is why your mood, your memory, your dreams all drift and bend. Sometimes from the smallest thing. In 1961, meteorologist Edward Lorenz was running a weather simulation. He rounded a number in his calculation from 0.506127 to 0.506. A tiny, insignificant change. But when he re-ran the simulation, the resulting weather pattern was completely different. This wasn't a bug. It was a revelation. Lorenz had discovered sensitive dependence on initial conditions, what would later be called the butterfly effect. He visualized it beautifully. Imagine a system like weather as a series of points swirling through space. He plotted them, and what emerged was not a simple line or a loop, but something strange, a swirling, infinite, fractal shape, like the wings of a butterfly, that became known as the Lorenz attractor, a visual proof that even deterministic systems governed by rules, can behave unpredictably. This wasn't just about weather. It changed physics. It changed biology. It changed our understanding of complex systems. The heart of the insight is this: small differences in input grow exponentially in time. So if you start with a system, a storm, a heartbeat, a stock market, and you shift the starting point just slightly, you might end up in a completely different future. You don't need randomness to create chaos. You just need nonlinearity. Think of it like this: a ball rolling down a hill will follow a smooth path. But now imagine that hill is covered in valleys, spikes, and slopes. A tiny push in a different direction, and the ball lands in a different valley entirely. That's what nonlinear systems are like. They branch, they split, they diverge with every passing second, and you can't predict exactly where they'll end up, not because we lack information, but because even perfect information can't overcome the instability of the system. One of the most famous examples is double pendulums. Imagine two arms swinging, one attached to the other. It's a simple toy, but once it moves, the motion becomes almost impossible to predict. It swings wildly. It flips. It loops in patterns you could never guess. Mathematically, it's chaotic, but it's not random, and that's the key difference. Chaos is not the same as disorder. Chaos is the appearance of disorder in a system that follows precise rules. It is structured unpredictability, like jazz, like improvisation, like life. The human brain is a nonlinear system. Your emotions, your creativity, your dreams, all shaped by patterns that are deeply sensitive. This is why some days spiral unexpectedly. Why a single memory can change your mood. Why healing isn't linear. Why love is unpredictable. Why art surprises us. It's why something you hear tonight, even quietly, half asleep, might ripple into a decision tomorrow. A thought, a mood, a moment of awe. The science of nonlinear systems reminds us we live in a world that is fundamentally sensitive, not just logically, but beautifully. And here's something even more poetic. These systems often form fractals. Fractals are patterns that repeat at different scales. Zoom in, and you see the same shape. Zoom out, and it's there again. Snowflakes, coastlines, clouds, blood vessels, neurons, even the branching of trees and the rhythms of the heart. All fractals, they are order inside of chaos, beauty emerging from unpredictability. A visual proof that even when the world looks messy, it is still deeply structured. So the next time something feels out of control or too complicated to understand, remember this: it's not broken. It's nonlinear. The world doesn't run on neat lines. It breathes. It flows. It shifts from one ripple to the next. And just like the butterfly, you may not always see the result of your small motion, but the pattern you belong to is real. Uncertainty. It's a word that can stir discomfort. We like to know where we're going. We like plans, calendars, forecasts. We like to think that today plus effort equals tomorrow, but the butterfly effect tells us the world doesn't always work that way. Not because it's cruel, not because we did something wrong, but because reality itself is soft and shifting. Even the tiniest changes can move the entire path. And so, we learn to live in a space that is delicate, ever-changing, and sometimes unknowable. Some people call this chaos, but others call it freedom. Uncertainty doesn't mean failure. It means possibility. It means that no story is ever fixed, that outcomes can change, that healing can surprise us, that the life we imagined at one point may gently become something better or simply different. The future is not a script. It's not a track already laid out in metal. It's an ocean current, flowing, splitting, rejoining, rippling around every rock. And like water, we learn to float, to stop resisting every twist, to stop fearing every wave. Living with uncertainty means softening our grip, letting go of the idea that we need to control every moment, every outcome. It means understanding that some days will surprise us, that not every effort will produce the result we expect, but that effort still matters, because every word we say, every kindness we offer, every brave act we take in the dark might shape something far ahead in ways we'll never see. The poet Rainer Maria Rilke once said, "Try to love the questions themselves, like locked rooms or books written in a foreign tongue." He was speaking of uncertainty, not as something to conquer, but as something to befriend. What if we learn to trust the fog? To know that we are still moving, even when we can't see the destination? This is not weakness. It's wisdom. Because in uncertain worlds, the only thing stronger than prediction is resilience. Let's pause here. Take a breath. Feel the air in your lungs. That breath is proof, right now, that you can exist peacefully without knowing what comes next. You don't need to solve the whole journey. You only need to arrive in this moment. The next moment will arrive on its own. This is the rhythm of nature. This is how flowers open, how galaxies form, how lives unfold, slowly, mysteriously, one quiet decision at a time. How do we live? With uncertainty, we listen more. We observe more. We hold our judgments lightly. We recognize that flexibility is not weakness, it's survival. When the wind shifts, birds don't complain, they change course. When the tide rises, ships don't freeze, they adjust the sail. We, too, can learn to move with life's invisible currents, to honor the mystery, to walk softly, knowing that small steps can carry great power. The butterfly effect doesn't demand that you control the future. It invites you to shape the present, to focus on the small, because the small is the big, the word of encouragement, the moment of listening, the willingness to start again. These are not afterthoughts. They are architecture. They are how we build a life worth living, not with blueprints, but with breath. Tonight, let go of the fear that you need to know everything. You don't. All you need is the next breath, the next gentle step, the next kind word, the next small action that aligns with who you want to become. The rest will unfold. Uncertainty isn't the enemy. It's the canvas. And now, with that soft thought resting in your chest, we move to the final chapter of our journey. You're here. You could be anywhere, in sleep, in thought, in silence. But instead, you've chosen to drift with me through this delicate journey. A journey of questions, of science, of history, and of mystery. And that, in itself, is powerful because your presence, your quiet attention, is not passive. It's active. It ripples. And in a world this sensitive, this nonlinear, even stillness is an act of influence. The butterfly effect teaches us that every small motion matters. But perhaps the most overlooked motion of all is simply being here, present, listening, breathing, becoming aware of your place in the pattern. You don't have to shout to echo. You don't have to lead armies or discover planets. You only have to live with care, to move with intention, to breathe kindly. Your existence has already changed the world in ways you may never know. The friend you supported, the stranger you smiled at, the moment you held your tongue, the apology you gave, the truth you shared, the silence you filled with presence. None of it disappears. Every one of those acts, no matter how small, has entered the web of reality. And somewhere, somehow, it shifted the future. That's the truth of all of this. Your life doesn't need to be loud to be meaningful. It doesn't need to be famous to be felt. You don't need to fix the whole world. You only need to touch the part that's within your reach. And you already have the as you drift toward sleep. Let that idea settle in. That's simply by being awake to your existence, by noticing the beauty in complexity, the chaos in pattern, the stillness in storm. You've done something rare. You've honored your presence, and that presence is not small. You're a butterfly, not fragile, but powerful in your subtlety. Your wings are thought. Your breath is movement. Your wonder is a force. Tonight, let the noise fall away. There's nothing more you need to understand, nothing more to control, nothing more to fix. Just breathe. In this soft moment, You've already created something real. A quiet ripple in a world full of storms. A thought, a feeling, a change that's enough. Before we close, I invite you, if this journey meant something to you, to leave a thought in the comments. Tell me, what moment in your life changed everything? What was your butterfly? Or what ripple are you hoping to make? I read everyone, and your words guide the stories we tell next. If this video brought you peace, I'd be honored if you shared it, liked it, or subscribed. This little space we've built together, called Science Beyond Sleep, is only possible because of you. One listener, one breath, one ripple at a time. And now, rest. Let the story fade like a distant wave. Let the sea of possibility carry you softly into sleep. The world will turn, the ripples will spread, and your presence will remain gentle and real. Good night, butterfly.